Everyone, I'm Devon Coombs, CPA, MBA, ex-Google and Deloitte. I'm a consultant in the Bay Area and also a lecturer at San Jose State and Ohlone College. And today I'm super excited to talk to you about one of my favorite money topics, the time value of money. And so I have a question for you all before I start this awesome lecture that I love and won't be boring at all. If I was to give you a deal and I was going to say, you go $100,000 in debt today and I'll give you a couple $1 million in 5 years, what would you say? Would you take the deal? Most of the people I talk to say, no way, Jose. No, thank you. I don't trust you. I'm not going to let you take $100,000 of my money in order to give me some kind of money in the future. What you illustrated, if you said, no, I will not give you the $100,000, is that money today is worth more than money in the future, even if it's more money in the future. There is a value to having your assets and money today. And the fun thing about this class and financial calculators and what we'll learn today is what is the value of that money, and making sure you can make a good decision of if someone was to come to you with an offer like that to quantify if that is a good deal or not. In many cases, we need to make investments early on to really get the compound effect of money, to really become wealthy, for businesses to make really good decisions. And we're going to learn that all in this really valuable concept. So the time value of money really summarizes that $1 today is worth more than $1 tomorrow. So if you had $100 today and you could invest it at 5% interest, you'll have $105 a year from now. If you only got $100 a year from now, you missed out on that growth. Most people would rather have $100 today than $100 a year from now. And that's because money is worth more today than it is in the future. You can think of that as inflation. You can think of that as opportunity cost, probably more appropriately. But the real value is having something in hand today has a degree of certainty. It's a degree of hedge against future inflation, and that you can invest it to make a return. That is the proof that money is more valuable today, but by how much is what we're going to be figuring out. And in order to know that, you need to first understand some basic concepts, the future value. So what money today will grow into in the future. And so if I was to tell you I was going to give you $100 today and you were to invest it at 8% year over year for the next 50 years, you could figure out what that looks like by using the calculations we're going to use in this lecture. The present value will help you determine the exact opposite of that. If you were to try to figure out if, let's say, you were going to get an inheritance in 30 years, you could figure out what that looks like in today's dollars and what the value would have been in order to help make decisions. So that could have helped us solve the problem at the beginning of the video, where is $1 million in a couple of years or a couple $1 million in a couple of years worth the $100,000 investment today? Other variables and definitions we need to understand is N, the number of periods. So we have our future value, where we're going to be in the future, present value, where we are today, and then how many periods are going to happen in between the future and now. This number in years in this class, but you can use this in months too if you want to get monthly compounding down. You could do it in days. You could really do anything you want. Years is the easiest for this class, and that's what we'll stick with. And then the last piece you're going to want to understand is your interest rate per period. So again, if this is in years, you would do it. If it's by months, you'd have to annualize it by taking the interest rate per year and dividing it by 12 to get into months. Sometimes this is written out as R or K. I like I, but really all you need are these 4 variables to get started with present value and future value of money, the time value of money. And those 5 together are going to be all you really need to understand time value of money and really start playing with fire here. So say you had $1,000 a day and could invest it at 5% a year. After 1 year, how much money would you have? And this will be your very first future value calculation. So we can go through it in the most basic formula. We're not going to require you to do algebra in this class or this type of math. Unless you want to, you could use a financial calculator, but I want to explain the nuts and bolts here because it's so important for everyone to get it. What you would do is you take your present value, which is 1,000. That's the dollars you have today. You multiply it by 1 times your interest rate. That's 5%. And you're going to get your $1,050. That's your basic algebra. I think everyone should understand how interest works to this point, but this illustrates a very simple concept of what future value of the money would look like if you were to have this fact set. Let's stretch it. What if you left that same $1,000 for 2 years, still at the 5% interest? Would you have the same amount, just another $50, or would it look a little different? And let's plug it in and do the math to see. You're going to take your present value and then your 5%, but now your N is 2 years. And so that's going to actually equal $1,102.50 because that $50 are going to compound, right? You're going to get 5% on that $1,050 in your second year. So you're actually adding $2.50 in interest on the interest. So that's the beauty of compounding. If you really do it over long stretches, you could be astonished by how much it can grow. A fun little game you can play is called the Rule of 72. A lot of times I'll do this when I'm trying to do quick math and make sure that my calculations seem reasonable. You could estimate the number of years it will take for an investment to double by taking the value of the fixed annual rate of interest. And this is a very powerful tool for estimations in meetings, interviews, or personal finance discussions. So all you do is you just take the 72 divided by the interest rate, and you get your years to double. And so if you're considering an investment that promises an 8% annual return, how long would it take you to double your money? It's about 9 years, right? 72 divided by 8, that's about 9 years. So you can just always take that 72 as your fixed constant, divide it by what your annual interest rate is, or your annual return rate, and you can figure out how quickly your money will double. What I like to do in my head is to take the rule of 10 years. So if you assume you had $100,000 today and you invested in the stock market, which has an average return of anywhere between 6 and 10%, you can say that on average, your money is going to double every 10 years. So if you have $100,000 today, you don't touch it, you put in the stock market, very likely in 10 years, you'll have $200,000. There's other concepts we'll talk about in this class, like dollar cost averaging or ways to hedge risk, but that's the fundamental easy way for you to figure out if your future value or present value are on track. The next question here is, when are you actually investing cash, or when are the cash flows occurring? So even one period of difference can really change present and future value calculations. And so the way to think of this is, if you are making a payment, you have to decide, let's say we're investing in your retirement accounts. You have to decide if you're investing on day one, the first day of your job, or on the last day of your job every year. And so that would be, are you paying an ordinary annuity? You're investing at the end of your year, or are you doing an annuity due? You're paying at the beginning of the year. Most assumptions that we'll take will be an end of period ordinary annuity, but there's going to be bond and asset valuation considerations where we'll need to have an annuity due. So you can take into consideration here, if you're trying to figure out the time value of money and you need to invest in something today, that's going to be more like an annuity due. While if you're looking at calculating interest revenue for yourself over time, that's going to be an ordinary annuity. So let's do $1,000 at 10% for 3 years. If you get interest at the end of your year deposits, that'll be $3,310 in total cash that you'll have at the end of your financial period. If you're doing it at the beginning, you'll actually have $3,641 because you're getting a whole extra period of compounding. And so that one extra period of compounding has a huge difference over time, and it ramps up pretty quickly. We'll illustrate this. I really like these charts. I used to actually just draw them on paper whenever I had a test. Your cash flow really has a period 0. And so you can ask yourself, on day 0, is any money going out? And then at the end of your first year, is any money coming in or out? What I would generally do is put on the top where the cash flows were coming in, and on the bottom where the cash flows were coming out. So here's a good way to show it with the cash flows on the bottom. If you have a $100 lump sum due in 2 years, I would just draw it out as the day 0. Here's your first year ending. Here's your second year ending. You'd have $100 at the end of the second year. And then you'd be able to figure out, I need to discount it 2 periods to figure out the present value if I wanted. For 3 years, $100 ordinary annuity, relatively simple. You look at this graph, but the ordinary annuity is at the end of the period. So you would say, okay, nothing on day 0. You put it on year 1, year 2, and year 3. At the end of the first year, the second year, and the third year. If it was an annuity due, you would bump that up. The 100 would be on day 0. So ordinary annuity, your payments happen at the end of the periods. Annuity due, they happen at the beginning of the periods. That's the big change there. You really need to understand where that timing comes, because it's going to have a huge difference on your calculations. So anytime you're doing a test, anytime you're trying to figure out a situation, you need to ask yourself, is this happening at the beginning or the end of the period? Where does this flow? And I would draw out this very exact chart on it and make sure you write out what periods have the inflows at what timing compared to the outflows. So when you're doing this, you need to make sure your financial calculator is set up correctly. So make sure that it's set up in years versus months, and make sure you get some practice with it. I'll put up videos that other people have done that are great on this. I don't need to re-record it for you all. The default setting is monthly periods generally, so that could throw you off. For the rest of their presentations and the rest of the course, I'll just keep you in the annual mode so you learn the topic. So you're going to see our financial calculators are set up beautifully, just the way we'd want them to be, because they cover every variable. They include number of periods, your interest per year, your present value, and your payments, and your future value. And all you're going to do here, it's kind of like a game. You're going to plug in the variables that you know. So if I give you a problem and it tells you the number of periods and the interest per year and the present value, you might need to figure out your future value. If you have the future value, you might want to figure out the present value if the present value is open. If you have all that information, you might be figuring out the growth rate per year, the interest. So you'll just see that you're eventually going to be plugging in these different variables and trying to solve for what is missing. So here's a good example. If your N is 2, your interest per year is 5, and your present value is negative 1,000. What is this telling you from a financial calculator application perspective? It is telling you that we are investing money for 2 years. We have an interest rate or rate of growth of 5%, and we are investing $1,000 as of today. Now, that's present value. So that's day zero money, right? That's not going to be end of year one money, that's day zero money. And then payment, you leave blank. We're not going to talk about payments yet. And we solve for the future value. And so what is that $1,000 at 5% look like? In 2 years, with it accrues and compounds, you're going to have $1,102.50. That's the same answer as we had earlier when we did the calculation using our algebra. So we get the same answer, and it's beautiful. That's the financial calculator, moves faster and can do some much more complex equations much faster. Let's go to scenario 2. You want $2,000 in 5 years, and you can earn 5% interest per year. How much do you have to invest today? So here's where it starts getting fun. Like, you all want to know about personal finance. Here's personal finance. All right. What we're going to do is you can take your goal. Let's say you want $10,000 for an engagement ring, $30,000 for a car, $1 million for a house, $5 million for retirement. You can figure out how much money do you need today in order to determine what you get in 5, 10, 20, 30 years. So let's do the math. First, you're always going to want to clear your TVM. You always want to make sure you clear your results from your last one. Always build that habit. You don't want to mess up your results just because you forgot to delete the last results. Then you're going to plug in your periods. That is 5 years. Your interest is 5%. Annualized, and your future value is $2,000. And we aren't calculating for payments, so leave that zero or blank, no ongoing payments. We calculate your present value. So that you should solve for it, and it should be negative $1,567.05. What does that tell you? Let's pause for a second. Cricket. It tells you that if you invest about $1,500 today, in 5 years, that's going to be worth $2,000. Now, hey, that's pretty cool. We can make that a lot bigger. And in my classes, we're going to do workshops to figure out what that actually looks like if you, let's say, start retiring or saving for retirement when you're 22 and leave it alone until you're 50. Man, these numbers can compound pretty fast. Okay, and so again, what does this actually mean? Why is the answer less than 2,000? Again, it's because money is worth more today than it is. Today's money is worth more than money in the future. And it tells you if you invest this money today that you're going to have a real value in the future. So again, the time value of money formula is really versatile. If you know any 3 of the 4 main variables, you can always solve for the unknown. This is just really great information because you should be able to take any problems I give you and just get a perfect answer as long as you can figure out which variable I'm posing. And so let's just do some practice. So if you solve for N, let's say you had $15,000 and you wanted to grow it to $30,000 and you know you can earn a 7% annual return. How many years will it take? Well, you could solve for that. So you just put your I is 7, your 7% annual return. Your present value is 15,000 out today. Your future value is 30,000. You solve for N. You get approximately 10 years. Well, that's cool to know. And that goes back to what our rule of 72. Essentially, you could figure out that your money is going to double in about 10 years. Goes back to what I asserted to you previously. This is a really powerful tool. You can now project into the future how much your financial decisions will impact your future self. And you can do this pretty accurately. Like, this is a pretty dead-on science that works out really, really well. Even stronger, you can figure out what money in the future, like let's say you're going to get a job in the future or you get a windfall in the future, what that's worth today and how you could decide against other outcomes based off of the financial ramifications. What if you want a stream of payment to last forever? Now, wouldn't that be nice? How many of us want just to retire and have $200,000 a year just magically show up into our bank account every year? This concept has been known for a really long time. It's called a perpetuity, and it means something that will last forever, and it has a very practical application in retirement planning. Perpetuity is an annuity, so that's a regular payment done periodically that provides a fixed payment stream that continues indefinitely. Now, the formula looks pretty funky. Your present value is equal to your cash flow or payment per period divided by your interest rate. So actually pretty easy math. The easy way to play this out for retirement, it's called the 4% rule. You can generally assume that as long as someone diversifies their investments, they can live off 4% of their total fund forever. So let's use the perpetuity math to figure out how much you have to have today if you want to live off $120,000 per year in retirement for the rest of your life. You take the $120,000, again, you're taking the cash flow you want a year, you divide it by 4%, that's the rate, you get $3 million. So your answer here is if you want $120,000 a year and you want to retire pretty comfortably and you have a well-diversified portfolio, you can easily get that money if you make $3 million. So then the goal is how fast can you get to $3 million if that is your retirement standard? You would generate $120,000 a year forever without touching the principal if you put $3 million in a 4% guaranteed fund, or if you had a diversified portfolio and looked at it historically and look at the real rates. Isn't that cool? So now we can all figure out how much money we actually need. I always ask everyone, what do you think is enough? And people go anywhere from like $1 million to $3 million to $10 million. And then I'll ask them, well, how much do you actually spend every single day? And they may be $3,000 a month I spend, or $100 a day, or $500 a day. And it's so far off from what their expectations financially are with their what this calculation would derive. So this is a really fun way to actually figure out what lifestyle would you want. Is $120,000 enough for your lifestyle? Is it $200,000? Is it $400,000? And then you divide that by 4% in order to figure out how much money you need to make. And then you can figure out your careers or how you'd invest to make that money. So you can figure out what your ideal life would be per month. You include your car, your gas, your rent, anything you can think of. And then figure out what your retirement number is and if you want to afford that lifestyle forever without ever working again. And there's other ways to retire early that I think are really fun that you can play with these variables. Like if you like teaching a light, like called Coast-Fi, where you can invest a little bit and still work a little bit and figure out when it compounds. Or you can think about Barista-Fi, Barista Financial Independence. Fi means financial independence, where you work for a while, for 5 or 10 years, and then you supplement that flow. Let's say maybe you make $1.5 million. And then you make $60,000 a year as a barista working 20 hours a week. There's really cool ways that the financial independence community has come together to figure out ways to make money work for your life than against your life. So there's a few other technical areas here that we need to layer in order to really do a risk analysis. My favorite one is scenario analysis. Time value of money tells you the value over time, but it doesn't tell you real world guaranteed outcomes. Like in the real world, stock markets drop for 10 years. Or in the real world, sometimes you get windfalls of cash and you win the lottery. You really need to make sure likelihood is valued into your decisions. What I like to do is always to include a few percentages of likelihood, maybe 3 different scenarios, like a very good scenario, a medium scenario, and a bad scenario, the percentage likelihood of each of those scenarios happening, and then you could calculate out what the true value is. And this is called scenario analysis. Okay, let's look at a common example. Let's say your friend comes to you and says, hey, man or lady, I need $10,000. Could you please give me $10,000? Then I'll give you $15,000 in the future. Well, if you believe there's a 100% chance that your friend will pay you back and you present value it at 7%, get a value of $10,695, but we all know that our friend could go bankrupt or not pay us back. We take a 50% chance and we multiply that by the $15,000 he's offering. So what you do is then take the $15,000 multiplied by that 50% likelihood you got, you get $7,500, and then you present value that $7,500, which you get at $5,347. So in that case, your $10,000 today is worth more than the $5,347. So this is a terrible investment and you should view other options. What could you do to improve your likelihood? And that's why companies have collateral, right? Like, hey, if you don't pay me back, I get your car. That's in order to take away some of the risk from financing risky people. So that's it. Now you have all the tools in your toolkit, other than payments, which we'll cover next class, on how to do future value and present value of money. You can figure out your payment terms, your number of periods, your interest rates. You can figure out your future value. You can figure out your present value. And if you're missing one of those variables, you can solve for the remaining variable. And now you can figure out things like how much money you need to retire and the 4% rule and the 72 rule. And you are a lot more sophisticated in personal finance than anyone who hasn't watched this video or taken this course. So great job. I'll see you next week. Have a great day. Bye-bye.